honestly, we jump this part. Oh, this part is important, about transmission, because it tells us the radio channels that are being utilized for downlink and uplink. Channels that allow us to communicate between the BTS and the mobile station, and these are the very famous frequencies that you are aware of. We talk about 900 megahertz GSM and 1800 megahertz GSM, and similarly, of course, for the uplink. What we must know is that they are divided between the uplink channels and the downlink channels. 100 megahertz range, and what you're saying is that each of those is divided between the uplink and the downlink. So the uplink is given for the 900 megahertz range is given 890 to 915, and the downlink is given 935 to 960. You can see some band gap there of about 20 megahertz, and again the uplink for the 1800 megahertz is given 1710, 1785. The bandwidth is equals to about how many? 75 megahertz. Then there is some band gap of about 20 megahertz. Then we jump to 1805, 1880. Again, the bandwidth of about 75 megahertz. That is quite significant. We can now just move on and just notice that we have observed that we are saying that the uplink transmission from mobile to radio is the one that is again, you can just try to know that when you're saying uplink, you're saying that it is from MS looking up. Say MSS is up and there, BTS is up and the MS is down there, so it is up, communicating between mobile to the BTS. Downlink, it is when BTS is sending the data to the mobile station. And we are saying that now there is a separation of 45 megahertz between the uplink and the downlink channels. And look at this. Are these really 45? Oh yeah, from this to that. Look at between 995 and 890. So the lowest for uplink and the lowest for downlink, the difference is 45 megahertz. You may just read through for your understanding the concepts of TDMA, the concepts of logical channels. You may look at them, and you may look at traffic mobile management. That is not of interest to us. What you definitely need to address is the idea of network configuration. That is the ideas of cell area, location area, MSC area, VLR area, and the PLMN area, and they are drawn in this figure light here. And the smallest one is the cell area. That is the one that has the MS area. And then we talk about the location area. They keep on increasing with distance until we have covered the entire GSM service area that is serviced by all member countries given that service. We have looked at the concept of a cell in the cellular concept that we studied earlier, and we have said that they are always in a cluster, and the cluster may have 7 cells depending on the design that you come up with. And the color in this scheme talks about the frequency reused cells. So everyone in LED is using the same frequency. So more or less that's a repetition. The ideas of location area, this is a group of cells. They are considered to be in one location area, and that again you may look at it more keenly. Then the concept of databases, and the first database that you meet is that of a SIM card, because SIM card stores your IMSI and your general details. So of course you can consider that to be your first database. Then you may of course look through this the remaining sections. The handover procedures, you make sure that you are able to read through, and they are quite straightforward for you to understand. They are again illustrated on this figure. That is one type of handover between A in a PSTN and B in a 1 BTS. Another type of handover is when we have A in PSTN and B in BTS2. Now, all these are the possible handover scenarios that you may meet. So, just need to understand in brief how the different scenarios may appear. You may skip this communication, or of course, I want you to read through that because it is maybe important about mobile or communication management. There are mobile originated calls and there are mobile terminating calls. They are not very detailed, therefore you may just have an overview of them. And the mobile terminating procedure, the idea of roaming now in general is addressed there. And roaming update, you may skip that. And the future of GSM may be the 5G. And last thing I want us to look at is this section. Observe what happens. We are talking about mobile originated calls. Let me go step by step. Let's start. So what we have is that we want this subscriber A want to make a call to a subscriber B in another MSC. So subscriber A wants to call subscriber B. Subscriber A wants to call subscriber B. So he dials his phone number right here. And once he makes that dialing, there is a communication to the BTS. The BTS sends a signaling request directly through the BSC to the MSC1. So we see that there is a connection established between first and foremost between the subscriber and the BTS, and then a request is sent to the MSC1. Now, once we have made that connection, MSC1 receives the dialed number and performs a pre-analysis in order to find out the type of call. And the result of that shows that a call is being made to an MSDN in subscriber B. So that knowledge is observed at MSC1. You say that MSC1 has a direct connection to the home location register database. So, but of course, MSC1 knows where, is able to determine by doing some analysis of the digits where the subscriber B is. So he identifies that there is a call that is intended to go to subscriber B. So what happens next? The MSC1 makes a like home location register inquiry to find out the details of subscriber B in terms of IMSI that are assigned to that subscriber B. We are given MSISDN that has been called by this guy. Of course, we are seeing that the MSISDN is part of this number. Of course, we have added maybe. Of course, it is that number in full. So we are trying to find out which IMSI number is allocated to the guy called subscriber B. So we are saying that the MSI and the VLR address of the subscriber B are found from the home location register. Then what happens next? The requests the HLR requests the roaming number from the MSC2. So what we are observing is that there is a routing address that is allocated to a given subscriber if he is not in the same MSC1 that our subscriber is, and therefore he has a given number that we are calling the roaming number. That number is fetched from the MSC where the subscriber B is located or being serviced from. And now the MSC2 reserves that roaming number from the roaming number pool. Of course, we are doing some routing of how we are going to be able to get subscriber B so that they can communicate with subscriber A. So we are reserving that roaming number from a roaming number pool. So we give this guy some number which you see is part of this column. You can see that now give that number to the home register, which now again pass the number to MSC1. This roaming number that has been given to MSC1 identifies the location of the subscriber B, because the roaming number identifies the exact location of a given subscriber. that we want to call. We move further, and we say now that we have sent request. Now the request is sent back to MSC2. The roaming number identifies its source as MSC2, so that this is the point of routing process. And now MSC2 checks from which the MSI number was reserved. What we must observe is that the primary key for a given subscriber is always the IMSI. So we are always mapping different numbers, one for the MSISDN and the roaming number to one IMSI. So the roaming now identifies its source, so that this is the edge of the routing process. And now MSC2 checks for which MSI number the roaming number was reserved. And we say now that now the MSC2 checks the location area. As I say that every area is given some location address. So the location address is of course saved as part of the roaming number. And we are saying that the MSC2 checks location area and the temporary mobile subscriber identification number for the subscriber B from the beta location register. When the subscriber B's TMSI and the location address are found, the MSC2 starts paging. And paging is now sending some signals, and I believe we have all of us heard. When we have some speakers in a given room, there is a tendency to have some noise indicating there is an incoming call. That incoming call is MSC, making sure that the given subscriber is in the location are last known or last identified. Asking the can I receive calls or can I send a call to you? And that is what you are saying, that is called paging. So MSC2 starts paging the subscriber B, and then once it has confirmed that subscriber B is in the location that it is expected, then we say that the call setup is completed, and now the MSCB receives the call that has been connected from subscriber A. That is quite a lengthy process that happens, but in a nutshell, it takes about 30 seconds or less for you to make a call between one subscriber to another.